So, you know, this idea of creating these fractal images on wood has been around a while. You know, this guy, German Lichtenberg sort of invented it, but recently it's gotten some press because people claim it's pretty dangerous. There's been some electrocutions associated. So this is my take on sort of what I call mitigating the risks that are associated with this. Let's see. So, you know, I don't want this, what we're here tonight, to be an approval of this process. I want you to view this, in my opinion, as you considering the risks and take that into account as to whether you want to do this sort of thing. You know, is that the whole? Yeah. So one of the issues that come up is, you know, people can be electrocuted pretty easily with this technique. There's some documentation on that. And I point out that as little as 5 milliamps passing through your heart can stop it. Now, there's probably maybe doctors or EMT people here that have had some experience with that. But what happens is if more than 5 milliamps passes through some area of your heart, it actually will freeze your ability to release this. And we've all had electric shocks where, you know, we can let go. But as the current increases through your body, it's damaged and you're not able to let go. So that's a serious condition. You know, unless you can get someone to arrive with those paddles in time, you probably won't make it. Yes.
I should tell you from experience, people who have pacemakers or defibrillators should never touch that.
Okay.
Anywhere near it.
There you go. I mean, I'm sure there are lots of reasons why you don't want to do this. Okay. But the American Association of Woodturners, of course, is really put thumbs down. They've recorded like 31 deaths associated with this over about a 3-year period. So I say to myself, you know, what are the risks? You know, again, this is data, right? 31 deaths in 3 years. Now, if you go to the internet, there's over 42 million references to this technique. You know, there's something like 266,000 videos that on how to build these generators or the videos related to it, and 54 of them specifically directed, 54,000 that are specifically directed towards building a generator on your own. So if you take the 31 deaths and you put it over in the numerator and you divide it by the number of generators, you know, it's one chance in 2,000 that you're going to hurt yourself. That's the way I sort of started to look at this. That's data. But it's something that you have to seriously weigh if you're going to do this. Oh, by the way, I have some copies of slides in case people want to sort of put some notes down. So, you know, my position, again, based on some experience, about 50 years of working in electrical systems, is that, you know, it all starts with the design. So if you're trying to mitigate danger, you start with the design. That's the starting place. And of course, the major objective of the design of the system is little chance of the operator body coming into contact with anything electrical. Okay.
Hey, try it now.
Okay, so as I say, that's what you start. You need a good design to start out with that minimizes the chance that when you operate this thing, that it comes in contact with your body in any way. And of course, what ensures that is a protocol. So how you use this. And you have to, and again, I'm advocating a one-person operation following strict procedures, okay, that are repeatable and that you say with that. Now, the last thing you want to do is really count on all the information you may get on the internet related to this. As we all know, that there's lots of great information there on how to do stuff. But when I dug into this, I found that a lot of the recommendations from an electrical engineering point of view and just a safety point of view were much too dangerous for me to consider. Okay, and again, I would consider that bad information. Now, I should point out that what got me interested in this is my friend Bill Hahn arriving with your table. That he wanted to actually do this on camera. He arrived with his generator, and we set it up outside my backyard so that we can burn wood, and we tested it out, and that's when it got me interested in this idea that maybe I can enhance some bowl turning that I'm involved with at this point with this technique. I'm not really interested in creating pretty pictures with it, but rather enhancing maybe some of the objects that I'm involved with. But really be careful about the information on the web, okay? And relating to this. So again, the generator design is relatively straightforward, but of course it starts with a source of 120 volts. You see that triangle there, what I call a power alert. So when you turn power on, you know it's on. There's a light flashing, there's sound going off, so you know that power is being applied to the transformer. You don't necessarily want to trust switches with your life. They can get stuck open or stuck closed. Okay. So the transformer then steps up the voltage to 120 to a couple of thousands up, maybe as high, depending upon the transformer, to maybe 12,000 volts. Of course, all the wiring has to allow for that. All the switches have to accommodate the current and voltage that are associated with that. Then there are probes, again. And again, you'll see some examples of the probes that we've been using. Now, transformer selection. Now, starting place might be an oil burner transformer. And the typical oil burner transformer generates 10,000 volts with a maximum of about 26 milliamps. Produces a slower burn. Some people think that's a safer approach to this project. Neon sign transformers, about 12,000 volts, 30 milliamps. Slow burn, again, people think it's... But then there's the microwave transformer, about 24,000 volts in the order of 400 milliamps that could be produced. It produces the hottest burn. You can control it with this device called a Variac, where we can vary the line voltage. But it's the most dangerous because it can deliver the highest amount of current that won't let you let go of those leads. Okay. If you remove that from a microwave, you're not done yet. You open up a microwave, there's also a capacitor in there that has a couple thousand volts on it. Okay, so even if this has been sitting on operating for a couple of months, you could still have quite a charge on it. So you got to be careful, which can be lethal. So, but those are pretty much the options for a do-it-yourself generator design. What you'll see here when you look at this, of course, is my microwave transformer. Okay. That I bought a microwave from somebody for $25. It's much cheaper than buying some of those other transformers. I bought an oil burner transformer. I think it was $70. Okay. One thing I wanted to mention too that is brought out by the American Woodworkers Association is that we're all familiar with the dangers associated with power tools, saws, routers, all things that just to tell you, in January this year, while preparing a blank for my lathe, I slipped and I took off a piece of my finger in a bandsaw. Who has accidents on bandsaws, right? But you get complacent, get stuck, you push a little bit, your finger's behind it, you lose a little bit of your finger. 7 stitches, I'm okay, but that's numbness in the finger. But so even though we're familiar with tools, we still make mistakes. But the margin for error With this, it's much slimmer. So that's why I'm advocating a pretty strict design and procedure. So here's the protocol that I'm recommending. If at all possible, you want to operate with two people. One person really operating all the equipment, but the other person is standby, just in case. You know, pull the plug, CPR, get the panel. Bill, you do know CPR? Yeah. All right, so these certain equipment and persons are not grounded. Okay, sometimes in electrical systems you want to ground things, but in this case, everything is floating. You'll see that when I showed the generator design, I had a rubber mat under it. That's what we've got here. I recommend that we stand on rubber mats just to be certain. Okay, particularly if you're doing it outside, there could be some dampness. So one person operates all the equipment, so there's no confusion about whether the probes are in position, whether the power's on and off. One person does all that. So the first step is we have to apply an electrolyte or something that allows for the conduction of electricity. That's really 1 tablespoon of baking soda to a cup of water. That's the starting point for electrolyte. Some people recommend more, but it depends upon the wood. It seems like, so the effectiveness of the electrolyte depends upon the type of wood, how long it's been sitting there, and again, we've made a fresh batch to make sure that it has the maximum potency. And of course, this is done with the power off. All these things are done with the power off. Double check the power's off before positioning the probes. Don't try to do this while power's being on. If at all, the basic rule with electrical systems, if at all possible, one-hand operation. Test if you go inside of a panel, you sort of bury one hand. You try to do everything with one hand, so this minimizes the chance that you produce a conduction to your body. I recommend that. Apply power after probes and workpieces are stable. You saw me fooling around with the probes before, trying to get it stable on that surface. After the power, apply power after the probes and workpiece is stable. Stop operation if the probes slip off the wood. Power off. Don't try to fix a problem with the power on. Just adhere to these things. Don't do anything with them. Now, what I'm advocating is hands-free operation. You position the probes, apply the power. Okay, get the burn the best burn you can, reposition it again. On the web, there's lots of people holding those probes, both hands. People are manufacturing products holding those probes. Even with rubber gloves, I don't trust that. There's some of the case studies that are on the wood turning. I talk about how people slipped and fell on top of them. His girlfriend grabbed them, and they all got a burn. They survived, but so I don't. There's people out in Oklahoma that are making a good living making these devices, and you use 2 hands. Again, I think you're taking a risk if you use 2 hands on something that's carrying 10,000 volts or 2,400 volts. So I'm not advocating that at all. So I didn't want to have a lot of slides, so this summarizes. So I'm still saying fractal burning can be still very dangerous unless you adhere to good design and protocol. That's what I'm here, I think, to push. So typically, after the first step is to apply the electrolyte to the surface, and sometimes you have to do 2 coats depending upon the wood. Now we're going to test it on a piece of cherry that I turned on this unusual bowl. And so we'll apply it, but sit for a minute, maybe apply a little bit more. Position the probes, okay? And what we should get is a current path through this electrolyte, through the wood. And again, it depends upon the wood, density of the wood. Again, this won't work on any wood that's been finished. So it's got to be, I I've sanded off some bolts and actually try this, okay? But this is a freshly turned piece of.
Jerry, what about the moisture content of the wood?
I'm sure that's a factor, okay? This was relatively green, green cherry, but I'm sure that is a factor. In fact, the one bowl that I really finished, this was green. I can see that I turned it green, it turned into an oval, you know, and then I tried the fractal burning on this guy. Now, one of the things that happens with fractal burning, it darkens the area of the wood. So there is a compound that I cite there called wood bleach that will lighten it up. I didn't test it on this, but I did test the wood bleach on an oak reject, you know, that went to the bottom of this guy, but I figured. So originally, it produces green staining on the wood. But here I applied some of that wood bleach. You can see that it lightened it up. So it does work if you want to reverse the darkening effect. I haven't completed all my experiments with that, but you can see that it does work, and I'm sure it'll react differently on different woods. But so my goal has been to really learn about how this works on different woods. I think this is ash, not mistaken. Yeah. So it works better on lighter woods, is what I'm learning, of course, and so the experiments will continue. Now, some people have gone to the extent of actually filling in the fractal burning with colored epoxy and sand it off to produce these very interesting pieces of art. That isn't something that at this point I'm interested in. The people who are doing this on a large scale, making bowls and stuff, like they can't keep these bowls on the shelf. You know, everybody wants a fractal burn bowl. But, you know, that's not my current interest right now. I'm interested in some of the technology and maybe perfecting some of the techniques so that I get good results in a safe manner. With that, I have a little concern about starting this up because it's going to produce some smoke. Yeah. And I see, Bill pointed out, we've got a sprinkler system in here. Now, we tested out the vacuum to suck off it earlier. It does work, but maybe we're talking about maybe a minute burn before it gets to those sprinklers. I don't know how sensitive those detectors are. Brian, I'll what do you think, Brian?
Sure. I think
you find it. All right, we can all. All right. So, okay.
You're not sensitive to smoke, just temperature.
Sprinkler is based on the temperature that causes the glass tube to burst.
Okay.
Usually when you see.
All right. So, let's see power. Let's see. That's the.
Lined on, that's the little glass in there.
The vacuum on it. The vacuum plug in it.
The vacuum,
Okay, so here's our first baking soda water.
It's going to be at the wrong angle. Yes, am I not?
Okay, make sure I got a stable probe situation. I do.
Steal your. folder.
You're even run it some.
Yeah, back there. Well, I better do it. That'll be my, this would be the standard way, let's get this out of the way.
Slide it under the table.
Yeah, we can do that, yeah. Okay, so basically, we're plugged in through this device we used to call a Variac, and this allows me to gain some more additional control over the amount of power that I'm applying to the probes. So I'm going to start it pretty close to the full blast for this demonstration. What we've learned is that as we want to get more detailed in an area, we might reduce the voltage, okay, to get finer lines, okay, and so we can turn the voltage down. But at this point, yeah, I'm going to go with pretty close to 120.
So,
Okay.
when you were paintbrushing
The electrolyte, yeah.
solution on the wood?
Yeah.
That's necessary to get
Conductivity, yeah. The wood itself is, it's dry, it's, you know, it's pretty much an insulator.
You paint that on any kind of a pattern?
We played with that with, Bill, why don't you take the table out now, sure. We played with that with, I mean, generally on these surfaces, I take what I get at this point. This is still an experimental process, okay? But when we did Bill's table, which initiated all of this, I wouldn't have done this unless Bill arrived with this idea of doing a table. And so we controlled some of it. I guess what we learned was that if you had one probe having more moisture than the other, that controlled the direction of flow of the electricity, okay? And so it's an interesting pattern, you know, tree light. And this was the table he's going to throw out, you know. Well, not big. Yeah, you put that table in there. So you haven't finished it yet, but you sanded it. It had a finish on it. It had a finish on it originally, right, Bill?
Right, yeah, it was worn, but it was still too much, so I had to sand off the finish.
Okay. I'm going to apply a little more of this because it's.
I was more trying to follow.
I'll turn the power on, Bill.
Only one person.
One person operates.
That's a solution.
If I can kind of squeeze.
Baking soda, 1 cup of water, a little warm, to a tablespoon of this thing. Again, people on the web say, well, these two, you know, depends on the wood you're working with, but this seems to work okay. Okay.
Explain this thing.
Yeah. Okay, so I have a foot pedal, but I don't trust my feet, so I use my hand, okay? So this is wired in series with the output of the Variac through an alert device that'll beep as soon as we apply power through the transformer to those leads. And so let's see what happens. You know, I'm standing on a mat here in case we. How they can talk. No, we didn't turn the feed. So, you can see that repositioning might be necessary if you want to. Okay, so get the idea, and I'm a little concerned about triggering something here. Now, the way you get the clarification, you've got to use like a brass brush and some water to clean this up. So this will show a lot of detail once you start to brush this off, okay? And you'll get some pretty fine lines that you can see that are on the table, okay? So that's the process. Again, I have confidence in this setup, and in the procedures, but again, I think everybody has to weigh where they want to build this. Now, this is a one box construction that I got the idea from the web, so everything fits into one box. Okay. Any questions at this point?
So it burns into it, right? So you.
Can you show it to the camera?
They fill it with the blue stuff?
Yeah, the epoxy, yeah.
Sell epoxy, could you epoxy the table?
Absolutely. Yeah.
Then you can sell it, make some money.
Probably,
You never know.
yeah,
There's a lot of stuff.
yeah. The people who are doing this, as I say, it's pretty popular.
Yeah.
With people who want to buy these things.
So you mentioned on the one slide about using lower voltage,
Right.
getting a slower burn. Have you found that either a slower burn or a faster burn produces more, like, I call it more of an intricate effect, or like you've got the lines you've got small lines, and then you've got wide ones.
Right.
I'm going to assume that the lower voltage then is going to get you those finer, smaller lines, and your higher one's going to get you much wider.
You're going to get a primary burn path, okay? I think I showed that last slide, okay? And then you'll get these fingers going off, okay? But, and the primary burn path is if you leave it there long enough in one position, okay? So but depending upon the grain of the wood and how much electrolyte surrounds that will determine how the branching occurs, okay? Again, this is not exact science. This is our best attempt at that. I don't know how many times we reposition the probes in order to get this effect, okay?
Several for an hour.
Yeah, it was an hour's worth of screwing around with probes. So, probably people who do this on a regular basis, consistent wood. The other thing is, I'd like to get some maple or some light wood, and I think it would look a lot better on that. I just got a bunch of ash today that I'm trying. But,
The microwave transformer,
right.
the wiring that comes with that is like 14 gauge. So you've got a couple of 14 gauge wires coming out of it. What are you transitioning to that heavy gauge from that 14
Yeah,
gauge?
so this is rated at about 20,000 volts.
Yeah.
Don't need that. The transformer is putting out a couple of thousand volts. But I've also have
No, what I'm saying is on the transformer, the wires coming out of it are only like 14 gauge.
yeah,
So are you just directly connecting that heavy gauge to the 14 gauge?
yeah, the 14, the maximum current this can deliver is about a half an amp, okay? So you don't need a heavy gauge wire, but it's designed, the breakdown of the insulation is in thousands of volts, okay? So that you don't get arcing someplace.
Giving the camera guys.
Yeah.
Really quick look there.
So again, this is my take on it. Again, something that lets you know the power is always on.
And, that's what the beeping was. I think that was probably masked by the vacuum, and I'll just, if I turn that on and just plug that back in, you can hear that. So there's something beeping all the time, but I've got an electrical connection.
So Jerry, when you have the probe here, you get that deep burn there,
Right,
all these little branches,
are also being produced.
they're just naturally occurring like
Yeah,
that?
yeah.
That's crazy.